For years, we've been told that Proxima b is our closest cosmic neighbor, a planet just 4 light-years away, almost within arm's reach if you think about it in astronomical terms. But there is a truth that is rarely spoken clearly. Proxima b isn't just far away, it is beyond our reach. Not because we lack technology, not because we haven't built the right engine yet, but because the universe, as it functions, does not allow that journey to happen. We like to imagine space as an ocean that we will one day cross, as a frontier waiting to be conquered. But the cosmos is not an open territory. It is a structure full of invisible limits. 4 light-years sound like very little, but it is a distance so vast that even light, the fastest thing in existence, needs years to travel it. And anything slower than light becomes trapped in a delay that is impossible to overcome. Proxima b is not an abyss that destroys ships, it's something worse. It is a destination that exists, but one we can never reach. This is not a story about human failure, it's a story about the rules of the universe. And when you look at them closely, you discover that there are journeys forbidden not by technology, but by reality itself. Proxima b was presented as a second chance, a rocky world in the habitable zone of its star, orbiting the closest sun to our own. For a while, it was easy to imagine it as a future sanctuary, as a possible alternative home. But today, we are going to set the fantasy aside and look at the facts. In this video, we aren't going to talk about science fiction, or optimistic dreams, or miracle technologies that don't yet exist. We are going to talk about real physics, about real distances, and about why, when you run all the numbers, the idea of traveling to Proxima b begins to fall apart. You will discover why 4 light-years is not a reasonable goal, but an almost absolute barrier. Why even the fastest probes would never arrive within human timescales, and why this limit isn't temporary, it's structural. But this isn't a video meant to destroy curiosity. It's a video to redirect it. Because understanding why we cannot reach Proxima b says much more about the universe and about ourselves than any promise of interstellar conquest. If you are interested in exploring the real limits of the cosmos without embellishments and without imaginary shortcuts, stay with us. Because from here on out, the journey isn't toward the stars, it's toward the reality that separates them from us. When we hear that Proxima b is 4 light-years away, the figure sounds manageable. 4, a small number, almost reassuring. But this is where language deceives us. A light-year is not a measure of time, it is a measure of distance. It is the distance light travels in 1 full year, moving without stopping at nearly 300,000 kilometers per second. To put it into context, light from the sun takes about 8 minutes to reach Earth. 8 minutes. That is already a massive distance on a human scale. Now compare that to 4 whole years of traveling non-stop. Even the fastest objects we have ever built move at a ridiculous fraction of that speed. The swiftest space probes barely reach a few kilometers per second. At that pace, reaching Proxima b wouldn't take decades, it would take tens of thousands of years. A concrete example makes it clear. The Parker Solar Probe, the fastest spacecraft ever built by humanity, would take more than 18,000 years to reach that star system. And that's assuming it could maintain its top speed for the entire journey, which it cannot. Here is where the true problem starts to emerge. We aren't talking about a long trip, we're talking about scales that break any notion of planning, of civilization, or of historical continuity. 4 light-years isn't just an inconvenient distance, it belongs to a different category altogether, a category where human time ceases to make sense. And this is just the beginning, because even if we could multiply our current speeds by 100 or 1,000, we would still be absurdly far away. The problem isn't that we're moving slowly, it's that the universe measures distances with rulers that were not made for us. The real problem with interstellar distances isn't that they are large, it's that we aren't prepared to imagine them. Our brains work well with meters, kilometers, even the size of a planet. But when we try to think about the space between stars, intuition breaks down. Numbers stop representing anything real. That's why we need to change the scale. Imagine the sun were the size of a beach ball. In that model, the Earth would be a grain of sand orbiting a few meters away. Jupiter would be further out, the size of a marble, and Neptune a tiny speck hundreds of meters away. So far, it all seems manageable, a solar system that could fit in a large park. But now comes the leap that destroys everything. If we kept that same scale, the nearest star, Proxima Centauri, wouldn't be a few kilometers away, it would be thousands of kilometers away. It's like placing one beach ball in one city and the next one in a different country. Between them, there would be nothing. No planets, no gas, no landmarks, only the void. This means that the solar system is not the first step of an interstellar journey. It is just the foyer, a ridiculous fraction of the actual path. Most of the journey toward Proxima b doesn't happen between planets, but between stars. And that intermediate space is so massive that it makes everything happening inside our own system irrelevant. When you look at the universe on this scale, you understand something fundamental. We don't live in a compact neighborhood. We live in an almost absolute desert, where every star is an oasis separated by impossible distances. And in that desert, Proxima b isn't just a bit further away, it's in a different realm of reality, a place you don't reach by taking bigger steps, but by breaking the rules that define space itself. Up until now, we might think the problem is just one of scale, that the distances are enormous, yes, but that with enough time and technology, we might be able to overcome them. This is where that hope breaks. The speed of light isn't simply very fast. It isn't a provisional record set by the universe. It is a structural limit, embedded in the very way that space and time function. Nothing with mass can reach that speed. It doesn't matter how powerful the engine is. It doesn't matter how much energy you are willing to spend. As an object approaches the speed of light, its effective mass increases, and the energy required to accelerate it grows out of control. Not gradually, brutally. Each tiny increase in speed costs more energy than the one before it, and as you reach the limit, the energy required becomes infinite. Infinite doesn't mean a whole lot. It means impossible. This turns the speed of light into something very different from what we usually imagine. It isn't a frontier that we will one day cross. It is a wall. A wall made of equations, not technology. A barrier that doesn't depend on our ingenuity, but on how the universe is built. And here is the direct consequence for Proximate b. Even if we could travel at a significant fraction of the speed of light, the journey would still be immense. At 10% of that speed, the trip would last more than 40 years, and that is in the best-case scenario, ignoring all other problems. Furthermore, time doesn't flow the same way for everyone. At extreme speeds, time dilates. For the traveler, the journey might seem shorter, but for the rest of the universe, decades or centuries would pass without pause. Traveling toward Proxima b wouldn't just be a spatial displacement, it would be a temporal disconnection. When you add it all up, the message is clear. The speed of light doesn't protect us from the universe, it separates us from it. And as long as that barrier exists, Proxima b will remain what it has always been, a real, observable world, but a physically unreachable one. When we reach this point, a reassuring idea usually surfaces. The feeling that even if we can't do it today, we will someday. The belief that the problem isn't the universe, but rather our current technological level. But that idea stems from a very common mistake: confusing progress with the absence of limits. Throughout history, we have overcome barriers that seemed absolute. We crossed oceans, we took flight, we reached the moon. And that has accustomed us to thinking that every frontier is temporary, that everything is just a matter of time, ingenuity, and resources. The problem is that interstellar travel does not belong to that category. We aren't talking about more efficient engines or denser fuels. We are talking about quantities of energy that far exceed everything a civilization like ours can produce, store, or control. To accelerate a ship to a significant fraction of the speed of light would require an amount of energy comparable to humanity's total production over thousands of years, and that is just to accelerate. Then you would have to slow down. Some proposals turn to antimatter, the most efficient fuel imaginable. In theory, it's perfect. In practice, we produce antimatter in ridiculous quantities at an enormous energy cost, and we have no idea how to store it safely for long periods. Other ideas look toward projects like Breakthrough Starshot, microprobes propelled by giant lasers, accelerated to extreme speeds. But even in the most optimistic scenario, those probes would be the size of a fingernail. They wouldn't be able to slow down upon arrival, they couldn't explore the planet, and they would take decades to send a signal back. It isn't a journey, it's a message thrown into the void. There is also talk of colossal structures like Dyson spheres, capable of harnessing the energy of an entire star. But building something like that would involve dismantling entire planets and reorganizing stellar systems. It isn't a nearby solution. It might not even be a possible one. When these ideas are carefully analyzed, they all reach the same silent conclusion. We aren't missing a piece of the puzzle. We aren't one discovery away. The obstacle isn't technological, it is fundamental. And as long as we keep imagining the trip to Proxima b as an engineering problem, we will continue to avoid the hardest reality to accept, that there are places in the universe that exist but were not meant to be reached. Let's assume for a moment that all technical obstacles disappear, that we find a way to travel at extreme speeds, that energy is no longer a problem, that the universe for some reason grants us passage. Even so, the journey to Proxima b would still carry an enormous price, a price that isn't measured in fuel, but in human time. A trek lasting decades or centuries isn't just a logistical challenge, it is an unprecedented biological and psychological test. The human body is not designed to live for generations inside a spacecraft. Constant radiation would damage DNA. The lack of gravity would weaken bones and muscles. Prolonged isolation would affect the mind in ways we are only beginning to understand. The proposed solutions usually sound reasonable on paper. Cryogenics, to sleep during the journey. Generation ships, where multiple generations would be born and die in transit. Or even the idea of transferring the mind into digital systems. But each of these solutions poses an uncomfortable question. Would it still be you? If you sleep for decades and wake up in a strange world, have you traveled or have you disappeared and been replaced? If your descendants reach Proxima b, was it you who reached the destination or did you simply send them? And if what arrives isn't a body but a copy of your mind, does that count as survival? Even if the journey were technically possible, it would cease to be an exploration in the human sense. It wouldn't be a round trip. It would be a definitive break from everything you know. Going to Proxima b would mean accepting that you would never return, that everything you love would be left behind, that the world that gave you life would keep moving on without you. And here a difficult truth emerges. Perhaps the problem isn't that we can't reach Proxima b. Perhaps it's that in order to do so, we would have to stop being what we are. When you put all the pieces together, the distance, the speed of light, energy, time, and the human cost, an inevitable question arises. A question that goes far beyond Proxima b. What if we are not an exception? What if no civilization in any corner of the universe can overcome these limits? This idea reshapes one of the greatest mysteries in astronomy, the silence of the cosmos. For decades, we have wondered why, in such a vast and ancient universe, we see no clear signs of other intelligences, why the sky remains silent. Perhaps the answer isn't that we are alone. Perhaps the answer is that we are all trapped. Every civilization might arise, develop, and disappear within its own stellar system, separated from the rest by distances that cannot be crossed. Not for lack of ambition, but because the universe does not permit large-scale encounters. In this scenario, the cosmos wouldn't be empty, it would be fragmented, divided into countless islands of consciousness that never quite touch. The Fermi Paradox then stops being unsettling, it becomes logical. We don't see anyone because no one can get anywhere. We don't receive messages because any signal dilutes before it matters. There are no galactic empires because physics makes them unviable from the start. And Proxima b stops being a special case, it becomes a symbol. The symbol of a universe where life can exist in many places, but where every place is condemned to look at the sky in silence. After everything we've seen, it's easy to feel a mixture of frustration and awe. The idea that the universe is full of worlds, and yet not one of them is within reach. But perhaps the mistake isn't in the limits themselves. Perhaps it's in how we interpret them. For a long time, we've looked at Proxima b as a promise, as a possible way out, a reminder that if Earth fails, there will always be somewhere else to go. And maybe that idea has caused us to lose sight of something important. The fact that we cannot reach Proxima b is not a defeat, it is information, a clear signal of how the universe works. It tells us that we don't live in a cosmos designed to be conquered, but in one that favors the near, the local, and the fragile. Life is not meant for escaping, it is meant to exist where it arises. Earth is not valuable because it is the center of the universe. It is valuable because it is the only place we can reach, the only home that doesn't require breaking the laws of physics to be inhabited. We are a young civilization looking too far too soon, but understanding our limits doesn't make us smaller, it makes us more responsible. Because if there is no second world waiting, then this is not a temporary place, it is the place. And perhaps that is the most important lesson of Proxima b, not that of an impossible destination, but that of an irreplaceable home. The universe may be immense, silent, and full of invisible frontiers, but here, on this tiny dot around an ordinary star, matter has learned to wonder about its own destiny. And as long as that happens, as long as we keep looking at the sky with curiosity, this corner of the cosmos is enough.